Right, so thanks guys for joining the third meetup. This session will be about machine learning kit Mendix provides. And I'll show you the POCs that I did also for one of the largest European banks. It's just a POC, just started, so the journey of machine learning will continue. I'm sure about that. Within that bank, but I also think that we'll also be introducing machine learning to and let's jump into more details. So today I'll introduce you to the Mendix MLKit. I will tell you about just a bit about technical foundation. I will show you how to work with the MLKit. I will mention the design patterns that you might use when you create your ML integrations. I'll tell you a little bit about use cases, but I think we all can use Google and we all can ask ChatGPT, just give us the 10 top cases for machine learning. So I'll just brief you into that. And I'll also give you a demo of MLKit together with the custom model that we created for the bank that I mentioned. And we'll end this with a QA session. Please note, I'm not a machine learning expert. I know almost nothing about how models work inside, right? I know how to integrate them. I know how to make them work in the Mendix application. But I won't explain how the model works in detail, right? I just know the input and output of the model, and I treat the machine learning models as a black box.
If there will be any question regarding machine learning model, then I can jump into the before and pick up the expert.
Yeah, exactly. Exactly. So we have people that do that in Capgemini as well, but I'm not one of them. So if you're asking what was the model, was it custom model, was it open model, I probably won't answer that. All right. So what is machine learning? You know, I'm a fan of ChatGPT questions, so this is the answer that ChatGPT gave me. I'm not going to read that. I think machine learning has been in the domain, in the IT domain, for quite a while now. I think we all know what this comes with and how to let's say leverage that. But there is something called MLKit for Mendix, which is something that I was interested in and I'm still am interested in, and I hope you guys will also like it. So MLKit, how to tackle basically machine learning within Mendix. You have two ways. Either you can call an API to an externally hosted service, which is easy peasy, lemon squeezy, you all do that, right? It's a REST API, any other SOAP, you name it. You can do it yourself probably. Most of you can, if not all. But then the interesting thing is the built-in part. And the built-in is that you can run your models within Mendix runtime, which was quite a revelation for me, when it was introduced, right? So I immediately started looking into that, and I signed up for the POC, and I did what I did, and I'll show you what I did. So how to start using that? Well, MLKit is basically a project that you can just download to your Mendix to deploy and build on top of that to create your POCs. But obviously, if you create a production applications, you will not start with that. But that's a good starting point if you want to learn how machine learning is or can be executed within Mendix. Be careful about the dependencies. When you download projects, some files are missing. You need to download it separately. That's because they're huge. Because the models are basically trained, and the data that they contain are just big. Right. So once you have once you've downloaded your application, you just need to start having fun. The MLKit contains both shallow and deep learning models. So some of them are very complex, and some of them are just like decision trees that you can just run. And what's cool is that the concepts of running the ML model within Mendix and the pre-processing and the post-processing, because those are things that you probably will be doing when you want to work with machine learning in Mendix, can be easily extended, right? So the custom code that you will learn, that you need to write, unfortunately, in Java, you can leverage to create your own pre- and post-processing routines. So technical foundations, what is, let's say, under the hood? We use ONNX, so it's an open neural network exchange format for running the models in Mendix. I think that, well, maybe not all, but the big players, they do have a way of exporting your models to an ONNX format, and once you do that, you are then able to run the models in Mendix. How many times I already said that? What's good about ONNX? It's an open format. It can be run on multiple hardware and multiple OSs, and you don't need to worry about that, right? So it will work the same on your Azure cloud, it will work the same on AWS, it works the same on your local PC, no matter if it's iOS or it's Windows. And it's part of the Mendix runtime, right? So you don't need to import or manipulate with your runtime, have any extra services running in the backend. That's all in, right? Mendix 2 Pro's got this, not Mendix 2 Pro, but the runtime of Mendix got this embedded. You don't need to worry about installing anything else. And some of the tools that I list on the presentation are the ways, or some you might ring the bell already for you if you read through that. This allows you to convert the models to ONNX standard. How do you work with MLKit? Well, if you already have the ONNX file, because you export it with your tool when you create your machine learning models, we import this to Mendix, right? It immediately produces an input and output mapping of the model, and that's your starting point, right? Then you need to create your pre-processing and post-processing routines. Those are usually Java, but you don't need to use Java, and I'll speak about that also in the following steps. And as I mentioned before, the Java samples are already part of the MLKit. So you can open the Java source code and read through that. Maybe you will find something that will suit the requirements you have for your inputs and outputs processing. Right, once you have that Java code written, you can execute the model within the microflow. Then you do your post-processing once the model has been executed, and then you process your outputs, right, as per the requirements. Whether it's third manipulation, maybe it's an input to another machine learning model, that's up to the requirements. Some tips and tricks that I've learned along the way. I've started using Mendix 24.1 to create ML integrations, and though that contains some flaws that I've only learned once I submitted a ticket with Mendix support, and they've suggested to start using 9.24.4. And then it works more or less pretty fine. What's good to know is how to debug Java code in Mendix runtime. And this will help you tackle any issues that you might have with your pre- and post-processing Java actions. It's also, if you don't want to use Java code debugging, you can also use some console logs to see whether or where within the Java you are at. And what's cool about Mendix and ONNX is that when you want to upgrade your machine learning model, the ONNX file, and you have the same input and output, you can simply upgrade the model, and you don't need to do any further adjustments. All right, some design patterns that are important when you work with machine learning. You can have advanced inference design patterns, so it's ensembles, cascade inference, so each output of one model is an input to another one. You can run machine learning models as a service, so if you have a microservices architecture, each of your microservices can host your separate machine learning model, and basically this all it does is just providing the output to the input that you provide. Again, as I mentioned, I treat machine learning models as a black box. And then batch inference. That's another design pattern. The pre and post processing design patterns. That's microflow activities. So an input to a machine learning model can be like either a matrix or a tensor, or it can be more of a simple data type. So it can be a string or a decimal, right? So it depends on the inputs of your machine learning model and outputs. You can either do it directly with a microflow, and then you don't need to do pre-processing or processing within microflow activities. You don't need to then go into Java code. In contrast to Java actions, which then you need to understand how Java works and how to write Java code, and there you do your processing basically just using coding, regular coding, high coding. You can also use ONNX operators for your pre and post processing. So this is something that encapsulates your model into new, let's say, or additional processing that will be used anyway in your ONNX model. So you won't need to look into details, but that's something that you need to apply on the level of where you create your machine learning models. So once you have your ONNX operators there, you can leverage that to not to needing to create your custom Java actions to process inputs and outputs of your machine learning execution. And hybrid activities. So you can mix microflow actions. So you can aggregate some data that later can be fed into your ONNX model, and you can combine them with custom Java actions that again can be used for further processing. The ML use cases. That's just as easy as asking ChatGPT what can be where machine learning can be used. So it will give you a pretty much very similar output. So image and video processing or recognition, natural language processing, predictive analysis, personalization, fraud detection. And fraud detection, I remember back in 2016, where we were using some algorithms for trade surveillance, where they were basically just well defined what needs to happen and parameterized, and there was basically a well-defined algorithm to detect frauds, right? You look into transactions, some of your positions on your bank account, and then there was this movement to maybe we should switch those algorithms to machine learning, right? And then some projects were started, and those are actually use cases for machine learning. More on the use cases is smart assistants, robotics, RT services management. I think we have a demo for that also in Capgemini, where we use machine learning for categorizing the tickets, right? Or severity, what needs to happen next with a ticket, and it's all based on machine learning. Document processing and management, that's also one of the cases that we will be performing POCs in the bank that I mentioned before. Compliance monitoring, so that's a case for also within financial services, employee training and development. You can imagine all other uses, I guess, as well. So MLKit demo. I'll need to switch the presentation mode. I hope all will work as expected. I'm not sure if you probably can't see that now. Let's stop that one. Let's change the way we options. Okay. So this is an application that I'm hosting locally, and that's the MLKit that I imported from the Git repository that is available online. And you can navigate there simply by just typing Mendix MLKit in Google, and it will show you the direct path to the repository. So what it contains some sample machine learning algorithm or models that can be used immediately, right? So there is this iris flower classification that's been done with decision tree, logistic regressions, random forest, and ensemble. So if you want to test that, basically what it's based on is you need to provide the 4 parameters. So length, width of sepal and petal. Right, so let's say it's 3, 3, 4, 5, and it will classify that it's a Virginica iris. Right? You've got an example of spam classifier. This one, unfortunately, I was unable to get to work properly. Maybe I just did not spend enough time on that. Then you have Titanic. That's basically a model that will tell you whether a passenger survived or not. The Titanic, some black humor. Then you have image classification. Now that's a funny one and interesting, because that's using a ResNet learning model. And what it does, it's basically once you upload an image, and I've got some sample images here. So let's say mouse, computer mouse. Right, it classifies this as a computer mouse or a mouse. So if you add, let's say, a keyboard, it will tell us that it's a keyboard. Computer keyboard, keypad. Then we've got tile transfer mosaic, right? This is where you can apply an image, and it will create a new output image based on your original, but applied with some like algorithms, right? So we've uploaded a mouse, and now we can see that the picture is basically created like created with a mosaic algorithms. Then we've got BERT. This basically can sort of answer questions based on the context. So it's almost like ChatGPT, but tiny little. So what you do is you provide a context to your question, then you ask a question, and then you get answers. Now that's not ideal case, because that's pretty small. The answer that it gives are pretty much well, generic, I would say. And the custom machine learning model that we've created is a recognizer of Tunisian banknotes. So what I can do, I can upload a Tunisian currency, let's say 5 dinars. Right, I run the model, and as output it tells me that it's 5 dinars. I can add another one. Let's say what we have in the sample is 20, and when I run it, it also detects that it's a 20 dinar banknote. But if you upload something else, just to show that it will not recognize it properly, we can upload a euro note. When you run that, it tells you it's a 10 dinar, which is obviously false, because it does not recognize that it's something else. All right, now you might be interested how to run, how to host, or not host, but how to incorporate the model in your Mendix application. So it's as simple as creating a machine learning object model mapping in Studio Pro. Once you've imported your model, it will create your input and output entities, which you need to feed to your model. That's an input entity, and the output entity is something that will come out of your machine learning module, exactly black box pair net light, as I like it. And how to run this? So once you have your input data, or something that you want to run your model against, you need to do first the pre-processing, and that's a Java code. And I did use pieces of code that were available in machine learning. I'll not show you in details, but I can show you just briefly how that looks. It's not very complicated. Recognizer actions. Right, it's so you see you just need to import the MLKit, your Java action, some further libraries if you want to interact with present files or on streams. And what it does, it basically takes the input file, it converts it into a matrix of floats, and it converts it to something that will be digestible by the model. It resizes it and basically chooses the input, but that's actually a post-processor. The pre-processor is here. Right. So importing the model, then mapping to different color scheme, resizing to 256 by 256, then performing calculations on the color, and then getting the tensor to a stream and then converting it to base 64. It might sound difficult, but it's pretty simple, and you need to follow that pattern to feed your model. And the output is something completely opposite. So you need to first convert it from base 64 to stream, and then perform your analysis of the output. So here you basically find the highest score that your machine learning algorithms gave you for a certain index, and then you map the index to, in our case, the Tunisian banknotes. So you see that 0 is 10 dinars, index 1 is 20 dinars, index 2 is 50, everything else is 5 dinars. Right. So basically that's it on the demo part. Now coming back to presentation. Oh, sorry guys. We're on slide 13, but we switched the orientation. Same problems as Tomek had, sorry. Alright, so we were here, the MLKit demo. Now, questions and answers, the thing I like the most. Do you have any? Yes?
Where the application you showed us from the model perspective, is that with all the certain modules you put in there, was that all coming out of the box? Or did you all implement it yourself?
So, you mean this view? This view?
Still on the
sorry.
But I mean all the different aspects you showed us, is that out of the box? Or did you get that data from somewhere?
Right, the custom model, banknotes recognition, or the other that I showed, for example, the recognition of the mouse, computer mouse.
Yeah, for example, yes, or the first one.
With the iris.
Yes.
So this comes out of the box from MLKit. You don't need to implement anything. You just need to download the application, run it, and it just works.
Yes.
Yes?
When he gets those banknotes and the picture files, if you crop only the euro, just so without that part outside, just that it was just a photo from it, would it work that the euro is that
Well, basically, the model that I showed you does not recognize euro banknotes, right? So it only recognizes the Tunisian banknotes.
okay. It doesn't have the knowledge of.
Yes, exactly. It does not have the knowledge. But we could feed the model with also euro banknotes and map them, and then when we provide the euro note, then it will tell us that's a euro. Yes.
Yeah, great presentation, thank you.
Thank
The question I have is, are those models running locally or in the cloud?
They are running locally. They are part of a Mendix runtime.
Okay.
So they're running on my computer.
Okay, is there a way of using Mendix locally but run the models in the cloud?
Yes, that's not a part of that presentation. That's where the API integration comes into place. So basically you need to define on the hostings on a server which hosts your models, your interfaces, and then you call those interfaces from your Mendix application and retrieve data back also by either same or another interface. Depends on the architecture of your solution. Yes.
So, as I understood, you built this custom model, custom case for this presentation. If it's not confidential, have you used MLKit for any commercial project already?
Not yet.
And any questions about that? And
Well, we are getting there.
okay.
So we've only started, feeding customers that there is ML capabilities in Mendix. We've got the POCs for that. We show customers the POCs, and we basically just started with that. But I'm sure this will come. Any other questions?
What's the impact on CPU and memory when you load that many models?
I haven't been monitoring that. But some of the models are 1 gigabyte, or 1 gigabyte of worth of, say, 1 gigabyte file. So there must be some performance here. I haven't measured that yet. That was not part of my research so far.
Okay. Because when you have public or private cloud, doesn't matter, you get the sizes, right? So you assign them. So with that many models, you would need to pay considerably more, right, for hosting.
Well, with that many models, right? Well, I guess it depends how many models you execute, right, at a time, how it loads your CPU, right? So you can have 10 models defined, but you don't use them, right? You use them. Well, I don't want to say every now and then, but you know what I mean, right? It's you pay per usage. But no, I haven't been monitoring performance or CPU usage. Any other questions? Nope. Okay, thank you for your attention.